So I'm going to be talking about state channels. How many of you guys have heard of state channels or know what they are? Yeah, I know you do, Mo. Cool, okay. Mo's going to also be talking about state channels afterwards in a slightly different flavor. Also very exciting. Cool. Okay, so I'll just start from the basics. So what is a state channel? Ethereum transactions are slow and expensive. We all know that. That's not great. State channels are essentially a way to batch Ethereum transactions, and how it works is, say A, we'll go with the traditional Alice and Bob names here. So Alice wants to pay Bob, but we don't want to confirm every transaction on the Ethereum blockchain because Alice pays Bob a lot. I don't know what they've got going on, but they're always involved in something. So they lock up funds in a multi-sig wallet on-chain, and then they move that balance off-chain, and they pass back and forth signed messages that update the balances. Now when Alice is done paying Bob, they can redeem put the signed messages back on-chain and extract the money with the appropriate updated balances. So what this allows you to do is send $1 payments every time without having to worry about paying gas or waiting for confirmation times. Super awesome. So that setup is great, but what if I actually don't pay Bob that much? And then what if I have other people that I would like to pay? That's maybe not the most ideal. So what I really want to do is set up a channel with one person instead of everybody that I have to pay, who can then forward my payments along and act as an intermediary for a lot of people who I have state channels with, or they have state channels with. Cent is a great application of this. They use state channels, and people set up a state channel on Cent, and then they're able to interact with other people on the Cent platform, instead of having to set up state channels with each person on the Cent platform that they interact with. So one construction, this is what Layne uses, is the Multihop, with HTLCs. And how that works is Alice and Bob set up a state channel with Ingrid, who acts as the intermediary between these two. I send a payment to Alice, which is locked, and then, to Allison's payment to Ingrid, which is locked. Ingrid then forwards it along to Bob, and then Alice directly sends to Bob the secret to unlock the message, which is then propagated back through the network. So one of the catches here is that you have to have these payments fully collateralized. So because the intermediary is acting as on my behalf in their channel with Bob, they have to have at least that much money in their channel to forward along the payment. So another way to do state channels and these virtual hopped applications through an intermediary is through virtual applications, or you'll hear them called threads, but it essentially works the same way, except you sign in a thread or an application into your channel state with your intermediary. So I say, hey, I want to open up a channel with Bob. I know you have a channel with Bob, so let's make this happen. We sign a virtual app into our state in the channel. Ingrid says, okay, I can do that. I have the collateral on both sides of the channel. We can do this. We establish a connection, that's step 2, between Alice and Bob. I pay Bob, it's great, I say, okay, I'm all done, and that channel, then the virtual channel or virtual application then decomposes back into payments in the original state channels between Alice and Ingrid and Bob and Ingrid. So that is all available right now in a variety of different applications or different companies' versions and frameworks. I'm going to be talking about Connext, obviously. So this is how our version 1 architecture looks. You have a client and a hub that communicate in a traditional client-server paradigm. And the hub has its own Postgres store, which stores all of the state. And you also have a chainsaw, which just listens to events on the blockchain. So the client and hub deposit funds into a multi-sig on the blockchain, and then they're able to do peer-to-peer payments in the same virtual application setup that we previously talked about. So what can you build on Connext today? You can pretty much do any type of P2P payments that you're interested in. You can do recurring payments or streaming payments, clearing systems, payments for multiple parties, payments that are unlocked conditionally. All very exciting. I'm sure you guys could come up with other things as well. Unfortunately, there are still some limitations to the version 1 of the architecture. First off, it's hub and spoke, which is great, but that means that you all have to have a channel with the same hub. So you're not really maximizing your channel benefit because you all have to set up with the same ingrid, which is kind of annoying. Maybe I don't want to have a channel on Sent, for instance, when I need to use something on Instagram or something like that. Another downside is that right now we only facilitate one type of token, which, you know, maybe I don't want to pay everything in DAI. Maybe I'm looking to pay in a different type of stablecoin. Another downside is we only allow payment types of state transitions, and that's great and useful in a lot of cases, but it's not going to be enough if you want to run a game in channel. So hub and spoke means no hub-to-hub communication. Other dApps can't access your channel. It's only two-party channels at the moment. And worst of all, you're trusting the hub to forward your payment because you're not holding on to your own copy of your state. So we don't like that here. So we are upgrading to version 2. And in version 2, we are rebuilding on top of the counterfactual protocol, which is a lot more flexible. So this is what the architecture would look like. You have a client and a node. Each has their own counterfactual instance in it, which is able to communicate using a peer-to-peer messaging system. And they're able to install various apps and virtual apps through the multisig and coordinate the installation and uninstallation updated state there. The client has its own key value store. The node also has its own key value store and a Postgres store that makes it a little bit easier to handle. But the same layer 1 to layer 2 transition exists where you have to deposit into a multisig on layer 1 and then you're able to update it with these fancy apps in layer 2. So one of the other huge benefits of using this counterfactual framework is that you're able to write more custom applications. So what goes into a custom application? Primary things are the number of participants in your channel or application, the state encoding, and the outcome from a state. So in this new framework, you essentially have an action and a current state, and you take your action, you apply it, and then you get a new state, which is great in payments. That's really easy to understand because if somebody goes offline, you still know how the payment would kind of propagate to get to a new state. That's not necessarily the case in games, so you can also encode new optional functionality into the apply action. It includes like, okay, was this action actually allowed? Like, can you make that move in the game? What is going to be the new state of the entire game once you have applied this action? And is this state terminal? Like, can I actually, if I'm playing tic-tac-toe, for instance, put another piece on the board? So that's for version 2. But we're also looking this will facilitate a move to version 2.x, which will get rid of the hub and spoke model, and in exchange we'll have Multihop, which is a lot more exciting. So the basic principle is the same, where you have intermediaries who, through some pattern, they're all connected to each other, and they're connected to somebody who you want to make a payment to. Anybody can become a hub and host like their own node and forward payments and host their own type of collateral, so that's really exciting. Some of the other benefits that come from upgrading to this multi-hop architecture and this counterfactual protocol are arbitrary asset support, so you no longer have to use just DAI or just whatever token you've deployed the contract with. You can do arbitrary state transitions, so it's no longer just simple payments. You have large payment support, and that comes through the multi-hop. So I mentioned before that collateral, every payment has to be fully collateralized. That's how the system remains trustless. When you have multi-hop, you're able to break a large payment up into multiple intermediaries. So say if I want to pay $100, instead of forcing the intermediary to collateralize $100 in the recipient's channel, I could break that up into 5 smaller payments through different intermediaries where they only have to collateralize $20. Another exciting thing is we're creating a channel provider which will give dApps universal access to your channel. So similarly, that in a way that wallets inject Web3 today, and you can create a new Web3 instance or Web3 provider, they'll be able to inject a channel provider, which means that they'll create either a new instance of Connext or a new instance of Seller and have access to update your channel all without having to create a new one on your behalf or without having to pass a mnemonic around. So that's also wonderful. Another great thing is multi-party channels comes in with the future iterations of the counterfactual protocol. And in other iterations of the counterfactual protocol, we're going to be looking at cross-channel interoperability. So if you do have a channel on Seller or a channel on Magmo, you're able to use the same channel provider regardless of which channel you set up. So I'm open to questions, but I'd also like to show you a quick demo of how this works now, how it looks. So this is, I'm leaving up the console log so you guys can see what's going on. I'm going to pull out my phone here because you do need 2 people to do a channel. Payment. So this is the MetaMask app. It's still in beta right now, but it will have channel payments integrated, so that's very exciting. Say I have, $9 in my MetaMask and I want to pay somebody on the DAI card. Okay, so what does that look like? On the DAI card, I can just click to pull up a QR scan here, and then on my MetaMask I click send, pull up my scanner, boom, got the address, and then say I want to send $2. Now when I go back here, see? You can see that the hub is collateralizing and I have a $5 payment. Thanks for keeping watching. So. All right, now are there any questions? Awesome. All right.
Cool. Thank you.